Hey, hello everybody, and welcome to a special episode of our Delta webinar series starring Daniel Beach today. We're going to be talking about the Polars ecosystem. We're going to be talking about AWS Lambdas and Daft and Rust. And without further ado, I'm just going to kick it over to Daniel. Daniel, welcome and thank you for joining us.
Sounds good. Thanks for having me. I'm excited to be here and talk about some fun stuff today. Hopefully Denny likes it. I'm going to talk about how we can kill Spark maybe. You never know what happened. Dreaming, but we'll get there.
Slowly and steadily, my friends. Slowly and steadily.
For sure. So today, the agenda for today, I'm just going to give a quick little background on myself. And I'm actually going to take a little time and talk about maybe a little bit of history around the lakehouse, data warehouse, kind of tooling around that. I think some of that context, I guess, and where we've come from kind of plays into what I want to talk about today, which is using not Spark to work with Delta Lake and using things like Lambda. So I just want to kind of do a little bit of a history lesson, like you're back in high school, talk about how we get stuck in these kind of old mindsets, and then talk about a new approach, and then we'll kind of dive into the topic of Lambda plus a bunch of different tools. We'll look at DuckDB, Polars, Daft, Python via Delta RS, things like that, and we'll do some examples, show you some code, and yeah, that's what we're going to do today. Yeah, so background me, if you don't know, I'm Daniel Beach. I'm a data engineer, been a data engineer for a while, well over a decade. I do content creation. You can find me many different places. You can find me on Substack, YouTube. I'm quite active on LinkedIn quite a bit. I have Confessions of a Data Guy blog that I've been doing for many, many years. I'm also got a big GitHub profile, so go find me those places if you want. And yeah, I don't have like part of why I like giving a talk like this is because kind of, not traditional way to work with a lakehouse. And that kind of fits my background. I'm not a traditional student of computer science. I didn't get a degree in anything like that. I live in Iowa. I got a degree in corn and beans and agriculture. Look at me now, I'm writing code, so anything is possible. Okay, so where to start? I thought a lot about how to start off this topic, and basically I want to talk about today using AWS Lambda and Delta Lake, and then a bunch of different tools to basically work with lake houses. And I think for a long time, if I look at my career and I look at, out there in the data space, what a lot of people do, it seems like we kind of get stuck in doing things a certain way. I see myself getting like that, right? I work on a data platform today that's primarily Databricks and Spark. 99% of it is. And, I just get used to doing the same old thing over and over again. I don't even think about it. When a new project comes along, a new data source, right, we just kind of go down the same road that we always do. But, if you actually take the time to stop and look at what's happening in the data space, it's super exciting. Things like Rust, things like DuckDB, Polars, Daft, you got all these amazing tools out there. And we have things like Delta Lake, which are incredible tools for the storage layer. And you can combine these things and actually create, whole new pipelines that don't have anything to do with Spark. And it's pretty amazing stuff. And you can save cost and complexity and architecture overhead. There's a lot of business value you can deliver to the business, bottom line dollars and savings, stuff like that. So that's kind of what we want to start. And I would say I'm going to start with like the end in mind. So what I want you to take away from today, from this talk, what I want you to take away is from don't be a lemming anymore. Just take a step back, new ideas lead to innovation. Just think about solving problems in different ways. There's lots of different ways. It's a classic engineering problem, right? If you give the same problem to five people, you'll probably get 5 different answers, and that's okay. And I think we should celebrate that and, take away this today. You don't always have to use Spark for everything, especially when it comes to the lakehouse. Well, we'll see that today. So here's going to be your history lesson, like you're back in high school. So I've been around the data warehousing for a long time. I think that kind of plays into the data landscape today, right? All that history kind of plays into how we got where we are today, where basically everyone thinks that they have to use Spark to work with a lakehouse. And, it does have its benefits, and a lot of people use it every day, and I use it every day. But there's a reason why we got here. And if we think back in time, where we all started with when I came into data warehousing, it was all SQL Server and Oracle. Maybe if you were cool, you were using Postgres, right? Things like Delta Lake weren't around yet. The lakehouse wasn't around. You just had these classic data warehouses that were basically relational database systems, sitting some SQL Server somewhere with a cranky old DBA sitting in front of it yelling at you, what are you running these queries for? You breaking my warehouse, stuff like that. And, over time, that created a lot of problems for people who've been around for a long time. They know those problems. We ended up with something called the data lake, which was basically the opposite reaction of that. We're like, well, if I can't do this on SQL Server, I'm just going to throw everything in S3 and deal with it, right? And that's kind of what the data lake is, and it solves some problems. And then today we ended up with the Lakehouse Delta Lake, which is the perfect solution. And so, like, historically, we kind of had two sets of tools that, we always dealt with. Back in the day, I started out, working on data warehouses in SQL Server with SSIS. That was basically your option. And, circa 2011, 14, Spark's coming out, but it really hasn't gained that much adoption, right? You kind of had to, like, pick your poison, right? It's like either people were on one side of the road or the other side. They were either working with a relational database. Maybe if they were cool, they were using pandas and MySQL or Postgres, right? Then you had all the big companies like, oh, we got these people that are doing Hadoop and HDFS and Spark, and it just wasn't as simple as it was today, right? In Databricks, you can go to Notebook and clickety-click, and you're running Spark. It just wasn't like that back in the day. And there's a lot of weaknesses that came along with, that Spark problem back in the day. It's kind of like you had to pick your poison. Which side of the road am I on? Do I have to choose pandas and run out of memory, or do I have to try to figure out how to set up Spark myself and configure the cluster and use HDFS and what's going on? It was an interesting time. A lot of brittle data pipelines, scalability issues on both ends, complexity. I worked for a lot of different startups over the years, and it depends on where you come from, right? Maybe if you work at a small startup, you just don't have the, you don't have the people to run a Spark cluster, or don't have the, know how to do some sort of, so you're stuck back on SQL Server, and that's just the way it is. So there's a lot of weaknesses with, getting stuck on one side or the other. And that's kind of when the data lakes came along, right? I still remember the first time I, went to a startup and they were dumping millions and millions of files of JSON and S3 and using Glue back in the day to, crunch those analytics, while at the same time they were running a typical SQL Server data warehouse, right? And I had to live in these two worlds where it was hard to marry this data, because some of it lived in SQL Server, and we had this other data that was really hard to work on over in S3. It was just really hard to combine the two, if that makes sense. And it just led to a lot of problems. And so I think when we talk about using Lambda and these new tools that we're going to talk about and look at, like Daft and Polars and DuckDB, all this stuff, I feel like people kind of, get stuck in this idea of, I have to use Spark. It's what we have to use. Pandas just doesn't work anymore. We pretty much are just going to use Spark for everything across the board, right? It just makes my data lake and my data pipelines all look the same. It's easy. I kind of fall in that trap of too, of like, it's kind of nice to have just Spark pipelines and that's it, right? Like, I don't have to go two different spots. Don't have two different sets of tooling. I'm just going to use Spark for everything under the sun, because at this point in our life, it works, right? You can open a notebook and just read a single CSV file, and that's fine. Or you can open a notebook and read 300 terabytes of data, and it just works, right? It's kind of beautiful in that sense. And so, especially when we talk about Delta Lake, I think that kind of like solved all their problems, and yet at the same time, it sort of made like the one-track mind of Spark even harder, because Delta Lake solved all these problems of like, okay, I don't necessarily have to run all these files that someone's dumped on S3, my data lake, CSV file, JSON, and I've got all this other stuff over in this relational database, maybe SQL Server, Postgres. I can actually just use Delta Lake now. I can use this single source of truth. It gives me things like CRUD. I can run update statements that I couldn't, over in my data lake. And now I have this, super simple, easy to use one-stop shop. And I'm just going to use Spark with that, because that's what everybody does. That's kind of what this slide talks about. Spark is not the only option anymore, and we have all these benefits of Delta Lake. And these are kind of like, can be a costly, especially for smaller platforms, smaller companies, right? This can be a costly way of, starting to data engineer everything of just Spark the whole way. with Delta Lake. It gets kind of expensive after a while when you don't necessarily need to do that. And so that's when we get to the topic for today, the new approach that I'm going to talk about and show you guys today of using Lambda and then a bunch of other tools to work with Delta Lake or your lakehouse. And I think it's really interesting that people even forget this is an option. They may think about polars and think about it in the context of pandas and, oh, it just replaces pandas. That's, stuff that people play around locally with on their laptop. It's not really in production, and that's simply not the case. All these tools, even DuckDB, are great to use in production. My company today, we're actually using polars, and I'll show you later. We're using polars in production with Unity Catalog Delta Lake tables to run production pipelines, and it's easy, quick, it runs fast, runs on Airflow Worker. It's a beautiful thing. Simple, low cost, fast. So I just want to I want to talk about Lambda a little bit here, because obviously we're going to look at some code, talk about how we can use Lambda, kind of the serverless lightweight architecture to run quick workloads in Delta Lake and for your lakehouse. But I'm not sure how familiar everybody is with Lambda who's watching or listening. So I'll just give a sort of a little bit of overview of Lambda. Lambdas are obviously super popular on AWS. They're what I would call like very little architectural overhead, very lightweight. If we think about, a platform like Databricks, right, to process some data, that's a whole different level than a Lambda, right? Lambdas are known to be small, quick, and fast. Really simple, easy to use. A couple lines of code and you can be running Lambdas. AWS provides all sorts of runtimes for popular things like Rust and Python. Lots of support around there. They do have caveats of like 15-minute runtimes, and they max out about 10 gigabytes of memory. But again, this is just about, like we talked about, so like kind of a mindset shift of how we think about maybe ingesting our data and using our data. It doesn't necessarily have to be everything at once with Spark. We can imagine different ways to get data into our lakehouse or Delta Lake rather than just all at once. So like those limitations, a lot of people bring that up about they only run for 15 minutes max, or they max out at 10 gigabytes. So it's like, yeah, that's true. But, we have new tooling nowadays that, won't run out of memory, right? It's not pandas. It will stream data really quickly, and they're very fast. And how often do you actually get a file that's bigger than 10 gigabytes, right? That's a quite large file. If you have somebody sending you a 10 gigabyte CSV file, you should probably talk to them, about that. It's not the best thing in the world. So it's just about, having a different mindset about approaching these things. And my examples will be using ECR, Elastic Container Registry, in AWS to work with Lambdas. It just makes it super easy and seamless, and the architecture and the overhead is very minimal. And I think that's kind of an important topic to talk about. It's that very low cost, low minimal, uncomplex architecture, right? That's the whole point of using a Lambda, is that it's super simple. Anyone can do it. And again, just talking about that mindset change of next time you're thinking about ingesting your data into a lake house, into Delta Lake, just think about the, frequency and size of that data that's coming in, and how, think outside the box, how I can ingest this data. Do I really have to have Spark to do that, or am I just using it because that's what I need? Maybe we just leave Spark for the middle heavy sections, right, of our data platform, where like, yes, we have huge tables and all this data. We need to run all these analytics over hundreds of terabytes of data. That's fine. That's what Spark's for. But maybe we can replace it on either ends. I tell people to think about their lake house and think about the data that's entering and leaving the lake house. A lot of the circumstances that I work in and seeing other people use, especially the data coming into the lake house and the data leaving the lake house going out the other way. A lot of times that is not necessarily big data in itself, right? It might be you're ingesting many small CSV files, or maybe you have a process that runs on your lake house. It may calculate some analytics, and then maybe it writes a small file out that gets emailed out to somebody, right, or sent somewhere. And that's a very, very common use case. And Lambdas are perfect for those things. And I just wanted to show an example here. This is how you can build and deploy. This is how I built and deployed a DuckDB Lambda that we're going to look at here in a minute. Using ECR to store a Docker image. So Docker is like the perfect tool, easy to use. You can containerize and package up all your requirements and code into this nice little container. And honestly, this is all it takes. This couple lines of code here, you can easily put this in a bash file. This is easy to put in some sort of CI/CD pipeline, right, where maybe you commit code to a repo and it kicks off a runner and it builds your image and pushes it out, right? This is anyone can do this. That's kind of my point. The architecture is not complex and the code's not complex. All it takes is 3 commands here and you can have a image out waiting for your Lambda to run. It's pretty simple. And I'm just going to pop out here and show you an actual example. So this is my personal AWS account, and I just wanted to show that, like we talked about, pushing those images out here. ECR is a great place to store your Docker images. You can see I've got a Docker, or I've got an ECR registry with a Docker image for each one of the Lambdas that we're going to look at today. I've got one for Daft, for DuckDB, I've got one for Polars, and I've got one for Python/Rust, the Delta RS project. Very easy. Again, when you think about, complexity and architecture, it's very easy to, manage this sort of thing, even in an automated way, right? There's nothing complex here. And here's the Lambdas we're going to look at today over in my account. There's, again, 4 of them. Very easy to manage, very straightforward. If you've never seen a Lambda before there, you can interact with them through the UI, of course, like I'm doing here to show you, but obviously, like anything with AWS, you can use the CLI to do all sorts of stuff with any AWS thing, including Lambda, and you can sort of automate all this stuff of like building and deploying the Lambdas, etc. So that's just kind of a quick overview of how easy and small the architecture is we're talking about here, which is a big, that's a win for us, I would say, right? Having, just less complexity. There's not complexity there. It's less cost, easy to manage, stuff like that.
If you think about like the use of DuckDB right here, you were talking before, like in your blog post from January, about how you're using tools that are very good for like either in-memory SQL. Do you want to talk to like the audience a little bit more about like why DuckDB on Lambda and what that's kind of yielded? Because you have the slide, so I'll just going back to you.
That's perfect. Yeah. So yeah, we'll kind of jump into the first one here, and we'll look at an example of using DuckDB with Lambda. Well, actually, in a minute, I'll show you the code. We can run it together. We can look at the output, and we'll do something like, I would say the example we're going to look at here is like sort of complicated, sort of not, but I made it complicated enough that it shows you the power of using these tools. Because another argument that I can hear is like, oh, well, I got to use Spark because this is a complicated thing, right? Everything that's complicated. I was like, well, there's lots of tools that can do complicated things. What are you actually doing here? So the example we'll look at in a minute is kind of like in between to show you kind of the power of this. Again, with DuckDB, I'm sure you've heard of DuckDB. Everyone has. It's just a great tool. I would call it one of the most lightweight tools that I've ever seen. Just a simple pip install anywhere, and bam, you have DuckDB and all the power behind DuckDB. It's incredible. I think it's just amazing to think about where we've come to. You can just pip install DuckDB inside of Lambda, and you can do just about anything you can imagine. It's amazing. I mean, think about how light that architecture is compared to something like Spark, right? There's no central configurations or metadata. You can just pip install it. You can combine. One thing I love about DuckDB that we'll see is you can combine it with all sorts of different data sources, right? So you don't have to worry about, how do I combine a CSV file with a Delta Lake with the Postgres instance, right? That's one of the nice things about DuckDB is they have a huge community, and that means they have, they have integrations with pretty much everything under the sun you can imagine, which makes it super powerful, right? Now we're just talking about, I want to read the CSV file and combine it with things that are already in my Delta Lake table, or maybe I want to go hit a database, and basically you're just using this one language, DuckDB, to basically talk to many different disparate data sources, whether it's Delta Lake or something else, and you can kind of combine that into a single SQL language. It's super powerful. It's super fast. Obviously, everybody knows that about DuckDB. It's SQL first, and then it's perfect for analytical workloads, which is perfect for the Lakehouse, right? It's basically one of the biggest use cases for DuckDB. And recently, I don't know how long this has been out, but recently I saw that DuckDB release some experimental integrations with Unity Catalog, which is pretty cool. I'm excited to play with that. But right now they do basically provide a delta scan method that can read Delta Lake tables if you know where it physically exists, right? That URI. We'll look at that in a minute. So I'm going to talk quickly about this pipeline that we're going to build together, and then I'll show you the code and we can actually run it together and look at it and look how powerful it is. So yeah, this is a typical data flow that we would see, right? So we're going to have a CSV file that's going to hit an S3 bucket, which is a very common use case, right? Here, a lot of times we use some sort of ingestion of flat files into our lakehouse like Delta Lake, maybe some processing going on if we have different bronze, silver, gold layers. So what we're going to do is we're going to have a CSV file hit a S3 bucket, which is going to kick off our Lambda that has DuckDB code. And then basically that Lambda, that DuckDB Lambda is going to read that CSV file, and we're going to write results to two different Delta Lake tables in S3. One being just like what I would call like a bronze layer, right? We'll just take some of that raw data from the CSV file, maybe cut it down a little bit, and just dump it into a Delta Lake table, very common practice, right? So we're like a raw staging table. And then what we're also going to do is actually have like more of a silver or gold table where it's almost like a cumulative table of that raw data, right? So we're just going to like roll that raw data up a little bit, like with a group by sum. We'll look at it in a minute, and then write that to a Delta Lake table all at the same time with AWS Lambda and a DuckDB. It's pretty powerful. And you can see it's very easy. All we have to do is create a Lambda, create a trigger for that S file, that CSV file hitting S3, and then just write a little bit of DuckDB code. It'll be pretty simple. I just want to show you a quick example. This is what the data looks like. So I'll show you in a minute here when we switch over to the live code, but basically we're just the data that we're using, the sample data is like a hard drive failure data set. So like basically if you think about a data center, they get a bunch of data that's like, oh, this model and this hard drive either failed today or not kind of thing, right? So that's kind of the data that we're going to be looking at, and we're going to dump that data into a raw table and then one into a cumulative table. So let's go look at the code. So again, I showed you this, right? We have our Lambda here. We've got a trigger on it, and I'm just going to jump over to the repo because you actually can't see the code here, right? Because we used a Docker image. Remember, I showed you this is where our Docker image is stored. And we just ran a couple of those Docker statements that allowed us to push this Docker image out into the ECR. And then we have our Lambda, and we'll jump over here and look at this Lambda. Again, I showed this before, but this is super simple, right? Just a Docker build command is all I have to do. And I just tagged it and pushed it out, and it's out there for my Lambda, super easy. Let's actually go look at this DuckDB code working with Delta Lake. It's thinking, here it goes. So again, we had, one second, I'll jump over here. So this is what the actual data looks like, right? This is one of the CSV files that we're talking about that hit the S3 bucket. I just wanted to show you what it looks like. It's actually a quite large file. It has maybe 250 columns in it of hard drive failures, right? We talked about, you can see a date, a serial number, a model, if it failed or not, pretty easy. So if we come back to DuckDB, and of course we mentioned we have that trigger here, right? There's already a trigger set up. You can look at it here. It's a trigger set up that says, hey, when this file shows up in this location, I'm going to trigger this Lambda. And so what happens? So this Lambda kicks off. It's a very small, simple Lambda. It just uses DuckDB and the Delta Lake project together. We get a bucket and key of that file that came in, right? Pretty easy. What you see here is DuckDB, just a couple of installs and getting the configuration for the access, right? When I built the Lambda, I baked in my credentials for it. That's just telling, hey, this is the AWS credentials. Just go look in the environment for them. So the first thing we do with DuckDB is we just read that CSV file, pretty straightforward. We select a subset of those columns. We cast it as a date, right? Just showing that you can do pretty much anything you want with SQL. Once we have that, it's really easy, right? All we'd have to do is say write Delta Lake. And we pass it our Delta Lake table path, which is up here of just basically our bronze layer Delta Lake, and it just goes ahead and it pushes those records into that table. You can see them showing up here. If I scroll down here, you can see this is just reading it in a Databricks notebook. I'm just reading that same location. And this is just our bronze, layer here that we just shoved all that kind of raw data into our Delta Lake. Super easy. And that's just a side note. Just remember how easy that was. Just 2 calls here, basically, of DuckDB to read that file and then throw it right into a Delta Lake right here. That's all it took. And then, of course, we have a more complicated portion of our pipeline where we said, now we have our second Delta Lake table that is a cumulative table. So what we have to do 2 things with DuckDB, and this shows the power of DuckDB, is that we need to read our current data that's come in, but we also need to combine it. Remember, this is a cumulative table, very common thing, right? Where we have a cumulative table that's just basically by date and by hard drive, and we can look at that table here. If we scroll down a little bit, we can see we can actually see the results here already, but basically this is our cumulative table, right? Which all it is just a roll up of the date in the model. So we're just saying, hey, somebody wants to know for each server model how many hard drive failures we have per day. It's a very common roll up, kind of analytical table. So can we do this sort of like complex thing? Like how could we do this with DuckDB and not Spark? Well, it's pretty easy. We can just use DuckDB to go ahead and query our current Delta Lake table. That is the roll up, right? It goes in and does a Delta scan of that rolled up table, and it actually goes in there and says for today, because we have this data set that we just got, the CSV file has dates in it, right? So we're saying we go to this other Delta Lake table, our cumulative table, and say, hey, give me all the records, the daily records, from whatever's in this file, because that's what I need to combine with the records that just came in, so I can update my cumulative table. I can write out and say, maybe we got some more failures. So that's pretty cool, right? Delta scan, we can combine it. We'll call that our current table, and then we go and combine it with the data that just came in. If we scroll back up, we call this Delta Lake table data, or this DuckDB table that read the CSV file. We just called it data. We can just union those 2 data sets. We can do a simple group by sum. We can actually pull the partitions out of there. So we just said, what days did we work on here? What days did we get? And we can actually write that back out to that cumulative data frame that now took the records that were already existing, maybe from today, and then we got new records, rolled them up, summed them up, and we wrote them back out to this Delta Lake table that we can go look at here. Here's an example of it. All right, so we've got a date, a model, and a failure rate. All with this little bit of code, and it's not much code, right? And so I wanted to show that this is, it's sort of like a play thing, right? Like it's not a real production pipeline, but it's complicated enough to show you that, we can do things with DuckDB that we didn't know we could do, right? I thought, easily we could just, do our bronze layer. We just shove the data straight in there with the Lambda, but we also did a little bit of analytics here, right? It just shows the power of DuckDB and the way we can combine, a CSV file with a Delta Lake. And, you can see here, I'm calling it out to an arrow data frame and then writing it into another Delta Lake. It shows you that flexibility and that power of DuckDB. And it's, sort of a play pipeline, but at the same time, it's like, okay, I can see how this is super useful, right? It's powerful. We did a pretty normal workflow here, and it all happened in a Lambda inside AWS with a little bit of DuckDB code, and we didn't touch Spark at all. And now we've ingested data into our data lake. I think that's pretty cool.
I think it's a good representation of like what you typically see in like that kind of like, it's like the first mile kind of pipeline jobs prior to getting into like that, as you were talking about like the more complex workloads. That was fairly complex for what it was doing. And in a lot of cases, like you're going to spin up a lot of clusters if you're taking a look at like the Spark side of what this would be. So at least 3 machines to go do a lot of that work, unless you're just running like, sole driver for everything else like that. So I think it's a really good use case for people just who are coming to this for the first time to take a look at that. Cause like I've seen a ton of jobs that look fairly similar,
Yeah, for sure. Yeah. It's a super common use case. And like I talked about in the beginning, it's, we're not saying we're going to kill Spark. We leave Spark for the middle, but we're talking about like the beginning and the end of our data lake and pipelines, right? We've got a lot of stuff at the beginning where, we're just taking files and shoving them in somewhere. That's like, 90% of what happens on a lot of data platforms. The first thing you got to do is ingest that data. And it's really just about a mindset shift of thinking, Lambdas are really powerful, right? We can schedule them with they can run every 15 minutes, or they can, like this example, it can trigger off an S3 file hitting, and wow, we don't really, today, I do a lot of that sort of workflow where I just use Spark and just shove it. You wait till it's all the data is piled up in one spot, and then I shove it in. And it's like, well, we can do that, but we can also do this, and this is powerful too. And not only is that, but we did a little bit of analytical workloads there, right? We did some group by sum. It's quick, fast. Like, there's definitely opportunity there, and I think it's almost up to the person, right? It's just like a creativity thing of like, oh, what else could I do with this sort of workflow? So I want
and just to add to your point, Daniel, like one of the key call outs about us using Lambdas, right? It's like, it's one less thing for you to manage, right? It's just, it's running. You don't have to think about it. And so when there is a change, it kicks in, it hits DuckDB, it hits Delta, we're off and running, nice and smooth.
Yeah.
Right? That's a serious win right there.
Yeah, it's very, very nice. I've started to use Lambdas quite a bit. It's just like you said, it's like an architectural, reduction where it's like, it's a less mind burden, right? For an engineer, somebody designing a data pipeline, it's just, it takes it because, Lambdas have been around for so long. The community is big. They're pretty hardcore. I mean, if something goes wrong, it's usually self-imposed, right? We foot-gunned ourselves for some reason. They're so bulletproof that, it's just, you never have to think about it, basically, right? It works because it does. So I wanted to talk about polars next. So everybody's heard of polars, hopefully. It's super fast data frame library written in Rust and has bindings in Python. It's kind of like the pandas killer, I would call it. Has a large community. There's a lot of stuff. I'll show you an example at the end where I'll show you some snippets from my production code that's running today. It runs every day in production. That is actually polars working with a Unity catalog Delta Lake table to do a pipeline. We'll talk about that later, but polars is a great tool. It's super fast. And what I want to do now is, we just watched DuckDB ingest some data into some unmanaged Delta Lake tables. I'm going to actually we're going to do something a little bit different here. So we're going to, again, show the power of a Lambda and polars and what you can do. We're going to do the opposite of what we did with DuckDB. Instead of getting data into a Delta Lake, let's try pulling data out of a Delta Lake Unity catalog table. So not just an unmanaged Delta Lake table sitting there, but let's actually try pulling data out and doing something with it from a Unity catalog table and write that data out to a file, which is, again, we just looked at DuckDB on the front end, right? Now we're going to look at using polars on the back end, which is another very common use case of, I have this Delta Lake table, I've got all this stuff in here. It's a very common use case of like, we need to run a little something and produce a file for someone, right? That's so common, whether it's email or SFTP it out or whatever, right? Throw it in S3 somewhere. It's a very common use case. So we're going to try to kind of take it from the back end now of like, can we use polars and Lambda to actually go hit like a Databricks Unity catalog table and do something with it? So that's what we're going to do. And the data set you see here is one I use quite a bit, Divvy Bike Trips. They put out, they're a bike sharing company. They have an open source data set that's basically their rides, right? Their rides of who took a ride to win type of thing. And let's go look at that code. Give me a moment here. Go through all my repositories and find the polars one. There it is.
Awesome. While you're pulling this up, a question came in about whether or not you find that the Lambdas tend to run out of memory more often, and what types of things do you do to mitigate out of memory exceptions?
Sure. So I would say back in the day, it could have been an issue. I've had that issue in the past because it does have a 10 gigabyte max. But again, I would say usually that was because I was thinking about the problem wrong. So either I was, instead of working, we'll talk, I think I have some slides later, we're talking about maybe we should process data in little chunks. We should try chunking the data instead of kind of the Spark mindset where it's like, I just pointed at this one spot that has everything and shove it over there. Yeah, Spark's great for that. But the other option is to DuckDB is fast, Lambdas are fast. Maybe I can just add a for loop and maybe I can just loop through these files or something like that, right? And then the other thing is now, today, with tools like Polars or Daft, these Rust-based tools are so memory efficient that unlike pandas, like, yes, you're going to have a problem if you try reading a 10 gigabyte file in a Lambda with pandas, because it'll read it all into memory and blow up. With these new tools that are built with Rust, they're very memory efficient and they're lazy in nature, sort of like Spark in the sense of they're not going to pull everything into memory. That will stream the data through. So as long as you, one, think about the problem right and use the right tool, like, Polars, for example, because it has like a lazy data frame where we can sort of like stream the data out of where it's coming from, say a CSV file in S3, and like back into the Delta Lake, right? We're not pulling everything into memory all at once, which these new tools like Rust are designed to do. It makes them so fast that you can overcome many of these sort of like limits with Lambda, like 10 gigabytes, right? So think about the problem different. Use a different tool that's sort of streaming in nature, lazy, like Polars or Daft, for example, and yeah, it'll totally read you can work with larger than memory data sets, right? Quote unquote, with these tools. If that makes sense.
Yeah, I think it's good advice for people. It's essentially kind of like how you keep things within iterators. Like, and so your idea of basically looping through makes a ton of sense, especially given that you want to basically batch things that are writing into Delta anyways. And on the reverse, not exploding and blowing up, memory and dropping the Lambda and having to reboot. That's great. But I think also that part of that comes down to like, operations, right? Like operational analytics that tell you, on average, what's the size of the data that you're pulling in? Are there outliers? Because this stuff happens all the time anyways.
Mm-hmm. Yeah, and I actually do have a use case I use in production today where we ingest all these files from one source, and like 99% of them are small and they work on a Lambda and they're processed on a Lambda. And then there's like 2 files out of like the 20 that get quite large sometimes, and they did cause Lambda issues, right? They blew up, and you know what? We just took that same code that was inside of Lambda and we just like plopped it onto Airflow Worker, and I was like, okay, on with my day, So there's just imagining different ways to solve the problem.
Absolutely. Tyler and I, when we had done our session about also Lambdas, right, and Rust, earlier in the month, yeah, that's exactly it. The vast majority of the files, no problem with Lambdas. At some point, you get large enough where like, okay, take the code, run it through whatever your job process that's more batch oriented.
Correct.
And you just literally categorize, okay, we know these 2 systems with these 2 partitions are going to go do it. No problem. Either that or you split the files, post-process, and then fine. And then it's back to smaller chunks and go nuts again, right? So whatever floats your boat, go for it, basically.
Yep, pretty much. So back to Polars here. Here's our Polars code. So let me switch back here because we talked for a minute there. So yeah, we're going to talk about Polars, and we're going to do the opposite of DuckDB, right? DuckDB is the front end, ingesting data in. We're going to do the opposite with Polars. We're going to use it to get data out of a Unity catalog table of Delta Lake and see if we can push it out. So kind of like on the back end of the process. And what's funny is like, this is just boring code, right? There's nothing here, which is a good thing, right? When I was working on this, I was like, well, no one's going to care about this. This is boring. I was like, wait, that's the best part of this, is that there is nothing here. There's nothing with the Lambda. And look at this Polars code. It's so simple. Polars has I'm not sure how new I think it's fairly new, this Unity catalog extension that they released, and it works great on this Lambda. I tried it many times. It's awesome. You can just see a simple code of like just passing, as long as you have your URI for your Unity catalog endpoint, and then a token, access token, which everybody's familiar with if you've worked around Databricks at all. You need those 2 things was it. And wow, look at that. I can just open up my catalog and I can say, here, I want this table, and I just pass it, right? My table, my schema. Look at that. Wow, that's amazing. So we can go look at that table. It's over here. This is the table I'm scanning. This is the Delta Lake table. I made it off the CSV file that we looked at before. I went ahead and created this confessions default trip data. So again, it's a bike trip data that we talked about. It's just like bike rides, right? It's a Delta Lake or a Unity catalog Delta Lake table, and that's all I did here was just, get a catalog, get a data frame off that table. Polars comes with SQL. I know everybody loves SQL, so all I did is a super simple, it could be whatever, right? It's kind of trivial what we're exactly doing here. Of course, I'm casting the date. The date that, and the raw data is kind of long and in a string. So I chop out the date and cast it as a date, right? It could be whatever. And then I went ahead and did a group by the date and count the number of rides. And I'm writing that file back out as like a metrics file. Maybe it gets delivered to someone in sales every day or something, right? And it's just amazing that I could do that with this little of code running on a Lambda. It's just incredible. I mean, I kind of feel stupid saying that, but as someone, like we talked about the history that we've came from, the ability to do this sort of interaction with the lake house, to run this on a Lambda with polars with just hardly any code. I just think it's so powerful. And of course, we got the result here that I wrote out to that CSV file. You can see it. It worked great. By date, it grouped by the ride type and counted how many rides are. And maybe that file gets sent out somewhere or something, right? It's just I think that's really, really cool that we could do that with polars, and it just took so little effort to do that. And polars is just like DuckDB in the sense that it's a huge community. There's so many, connectors. It can talk to pretty much any data source you ever wanted. So just the power of being able to do whatever you want, talk to any data source, encapsulate it all. It's just it's pretty neat. And we're going to do Daft quick. Just watching my time here to make sure I'm good. And it's interesting that someone just asked a question about like blowing up memory. And I said, let's use a fast tool, a good Rust-based tool. And that's what we're going to look at with Daft really quick. Is if you've never heard of Daft, I think it's like one of my favorite tools. I think it's an unsung hero. It's super, super cool tool. I would call it similar to polars. It's a data frame based library, although it does also have a SQL API. So you can just write SQL with it if you want. It's got a Python wrapper to a Rust library. That's what Daft is. And it has, what I love about Daft is it has, unlike some tools, it has both read and write support for Delta Lake. And they also have, I think they were one of, at least in my knowledge, they were one of the first ones that came out with like a Unity catalog extension. So they've had that for a long time, and I've been using that for a while, and it's great. So what I did is I actually made a 10 million line CSV file and thought, can I take this, and this is sort of on the ingestion side, like, we've looked at like some play examples, some like sort of code, but what about like a big file, right? Like, what's this actually look like if I make a 10 million line CSV file and try to dump it into a Delta Lake? What's gonna happen, right? Is it just gonna blow up because we can't use these tools like this to do it? So let's go look. Pull up the code again. And again, it's going to be very boring code. I'm just going to warn you. And just to prove it, I can show you the file here, Daft large data. You can see I'm very original with my names. You can see I've got a 1.1 gigabyte file there. That's got all that data in there, 10 million lines. Just so you know, I'm not lying to you. I actually did this. And where's my Daft? Daft. There we go. And again, this is going to be super boring, which is a good thing. Go in here. Let's look at the code. Again, this might even be more boring than the polars code. I hate to say it. It's like less lines of code.
No, you don't hate to say it. You love to say it, because that's the whole point. It's boring. That's great.
Very boring.
That's awesome.
So all we do here is we set up some access, right, to my AWS, and I just say Daft, read CSV, pointed at that large CSV file that we just looked at, 10 million lines in there. And I go ahead and collect it, and I could just write Delta Lake. This is crazy, right? I mean, this is like no code. How is this possible? And it's just a little tiny Lambda. How's it going to be able to process 10 million lines? It's going to like run over the 15 minutes. So when I tested it, it took 3 minutes and 30 seconds for it to do that, which is like not that long, right? That's 10 million lines. That's quite a bit. And that's, I don't think that's that long, right? Some people might think, oh, it's 3 minutes and 30 seconds. It's like, well, it's 10 million records. That's quite a bit. How many records are you getting a day? Sure, if you're getting 10 trillion records, then maybe you probably shouldn't use a Lambda. But for most people, I'm just showing you that, there is production. This stuff is production ready. It's 10 million lines. It's a gigabyte CSV file, and that was 3 minutes. I mean, I'm sure we could mess with my 4 lines of Daft code and make it faster, maybe, but it's definitely just showing people that, this stuff is possible to do easily. And again, I think this was the one we kind of talked about before, and somebody asked a question and talked about rethinking how we solve these problems. This is kind of the slide I was talking about. I think it's just about a mindset shift, right? Do we stack all the data and try to, what we talked about, eat it all at once? Are we like data gluttons? Do we have to like chew it all up at once, or can we like go on a diet and take it one little piece at a time with Rust, right? Or with Lambda? I think we just saw that we can do that, with Daft, with DuckDB, with polars. We can, if we just reimagine the way we're thinking about some of these data ingestions and data coming out the other end, this Lambda is the perfect tool for sure. And then I know we're running short time, but I did want to show.
Before we start this part, just because it's a series of kind of questions have come in through,
Sure.
Do you want to answer just a quick question? And this always comes up when you have systems like Lambdas in general, step functions, etc. It always kind of comes back to testing. And so if you think about testing, you're going to be testing just the code in the small, but are there any other kind of limitations to testing and then what actually runs in production? Have you run into any kind of stumbling blocks with this architecture?
Not really, mostly because, again, if we go look at, let's say this was actually this is actually a tiny mini repo, right? This has a Docker file with it, has a requirements file, it has just this stuff sitting here. So absolutely not. I mean, look at this. I could go into this repo. I could, obviously this is production, we could encapsulate this sort of logic into functions. We could just add a test folder here. I could write some py test here, and I've already got a Docker file, so we could maybe automate that and say Docker compose up test, unit test all the code within here that's running, right? If it was production, as well as, of course, I think one of the nice things about this sort of Lambda setup is that it's so easy to build and deploy this sort of architecture, with this sort of, we looked about, how easy is it just to, as part of you make a commit to this repo, and then part of the GitHub runner builds a test and deploys out to a test Lambda and just triggers it or something, right? It would just be, the code would be that big to test, in my opinion, to test both the code and to test the Lambda. If you want to test it yourself running or something like that, it would be pretty trivial, just because there's hardly any code here, right? The architecture is so simple that it makes it possible to do stuff like testing easily.
Awesome. Thank you.
I think this is the last one I wanted to talk about before I got into some of the, I'm going to show some examples of, it's some of the actual, like I said, I had some polars code actually running in production today. I wanted to actually show you an example of what that might look like. But again, this is going to be super boring code. I did the same thing with, I do have a repo I could show you with actual Rust code, like Delta RS Rust reading, but I know probably most of the people here are Python people. So the Delta RS project is awesome. It has Python bindings, and it's just one of the coolest projects ever. And I just wanted to show you again. I just want to show you an example of doing the same thing we just did with Daft. So that 10 million line record, I did the same thing with, if I can find it here, Python Rust Lambda. Yep, I did the same thing with the Python wrappers for the Delta RS project, just to see it. And again, this is the same 10 million record file that I did the exact same thing with, you can see. And the code is just as boring. I just used the Delta Lake project, the Delta RS project. That's it. That's all I did. Did the exact same thing. And it was a little bit slower. Denny's not going to like that. That Daft was faster than Delta RS, but it took about 4.5, almost 5 minutes to do that.
No, it's perfectly fine. And we're updating Delta RS by Python.
There you go.
With the latest of Arrow, Data Fusion, and everything else. So that speed will go back up too. And this is not in competition with Daft or Polar. Correct. We love Daft. We love Polar. So I'm just saying, don't be knocking Delta. Come on, just don't knock it. That's all I'm saying.
That's true. And I just wanted to show as well quickly here that forever you've been able to use it. You could, if you just love Rust, like then you just want to like, I don't want to write Python, I want to write Rust all the time. You can easily read and write, files like this with just Rust. You can see this is another project I did about 3 years ago. Look at this. 3 years ago, I was using Delta RS to like open up Delta Lake tables and read CSV files and write them, dump them with, that's not that complicated. You don't know Rust and you can still figure that code out. And I'm bad at Rust, so that tells you something. So just like you can get this done any multitude of ways, right? Get back here. So yeah, lastly, I wanted to show you guys a quick sample of a snippet of code that's actually running in production in the data platform that I work on today. And it's based around Airflow and Delta Lake and machine learning pipelines. The company I work for, we do a lot of machine learning stuff. And I actually had this sort of strange, you get into machine learning sort of pipelines, it can be a little bit weird sometimes, not your normal stuff. So I had like this use case come up where, we've kind of been all in on Delta Lake. It's an awesome tool. Like I don't even use Postgres anymore. It's like, forget it, man. This is Delta Lake all the way. I don't need that. So I actually had this use case where I had this, Delta Lake table that was being populated from a, just normal Spark pipeline, but I actually needed the individual records out of that Delta Lake table to kick off a bunch of downstream pipelines to basically like train models. Like, so if that makes sense, I have a Delta Lake table and then I need to go hit that table and get, maybe 20 records out of that Delta Lake table. And each one of those I needed to like kick off a downstream pipeline in Airflow, like a whole complex machine learning pipeline, right? Very complex DAG. And this is like how am I supposed to, if you're having the typical mindset, you're like, dang it, my data's in Delta Lake. What do? I can't do that. How am I supposed to do a Spark? I can't kick off Airflow pipelines with Spark. That's crazy. How am I going to solve this problem? And basically, this has been running in production for over a year. I just used Polars because it was one of the first, Polars had Delta Lake support a long time ago. This is a Unity catalog table. At the time, this was when they didn't have the Unity catalog integration. So I just, read the raw URI of that Delta Lake table. And this is an actual snippet from the production code where this is running inside an Airflow worker, just to make that clear. This is all inside Airflow worker, so it has nothing to do with Spark. Basically what happens is Airflow worker, you pass it a path of a Delta Lake table. In this case, it was a Unity catalog table, and it just read that Delta table very easily, right? And it pulled all those records out into a data frame. And basically, you can see here, it's passing the path of that Delta Lake table, and it's going ahead and reading that Delta reader that we just saw. It reads it into a data frame. And in this case, I'm filtering it down to a certain job ID, right? Some job ran, and it populated this Delta table with a bunch of records. So I went and hit that Delta Lake table record with Polars and an Airflow worker, pulled it into a data frame, said, hey, I'm interested in this one job. And after this is what happens next. And I sort of commented out some code in the middle there, but basically what happens is on that Airflow worker, I would go ahead and take those records from Polars and I build up basically the arguments that I needed from that Delta Lake table and pass them, kicked off other DAGs inside Airflow, right? So all of a sudden, I kick off one Airflow DAG, it goes and hits the Delta Lake table, pulls those records back with Polars, and then all of a sudden it floods off, got all these different configurations out of the actual records lines from my Delta Lake table, my Polars data frame, and kicks off these downstream pipelines. All 20 of them are however many in that job ID. And this is pretty cool. I just wanted to show you that real life production use case. So it's probably been more than a year that's been running, and I didn't use Spark to do it. So it's just about that mindset shift again, like we talked about. So yeah, closing thoughts. Lambdas are awesome. They're lightweight. They're simple, easy to build and deploy. I think that's one of the biggest draws to them is, low cost, low overhead architecture. They're flexible. Think about everything we just saw, DuckDB, Polars, Daft. I mean, it's incredible. This is the different tools out there that could throw anything inside of Lambda if you want. I could put Denny inside of Lambda if I wanted, maybe, I don't know. And it's just awesome. We can, just reimagine the way we think
I'm too fat, dude.
Yeah. I was thinking too old, but maybe that's me. but yeah, just reimagining how we think about these pipelines and working with Lambdas and your Delta Lakes and your lake houses. You don't always have to use Spark. Spark's awesome. I use it most of the time for 90% of the things, but there's all this other stuff around the edges that I think if we just like get out of that mindset of like where we grew up in, oh, it's Spark for everything, that there's many other options out there and they can be very flexible and they can reduce costs, they can reduce complexity, and they're kind of fun to work with, I think, and easy to work with. So yeah, that's my talk.
Awesome. Thank you, Daniel. This was fantastic. There's people from the audience who are wondering about like, just kind of goes back to like limitations again. And if you think about like polars versus like a Spark data frame, without like the entire cluster behind you, what are other kind of problems that people would run into when switching over to this new architecture? I know you've covered a lot of this before, but was there anything that was like stumbling blocks when you first made the switch to polars and kind of moved away from like kind of the typical Spark data frame like concepts?
Yeah, a little bit. I mean, I think it is, again, it's just a mindset shift of like this being more cognizant about the data you're working with. I think it's easy to get in like a Spark mindset of like, I don't even have to think about the size of my data. I can read like one CSV file or I can read 5,000 of them. I mean, it just doesn't, you get into this thing where like, I don't really have to think about the data size, which is not necessarily a good thing, right? Because then if you have that sort of mindset, that probably means you're not thinking through your data sizes very much and how you're processing the data. And it probably means maybe you haven't tuned your Spark clusters. Maybe you just like clickety click and I'm using like some massive Spark cluster to do this one little job and wasting all this money and resources, right? Which is probably the case if you don't know that granular detail about your data. So I think it was just a mindset shift for me of like, oh, I actually have to understand my data and the way the data flows at like a very minute level, like how often is it coming in, the volumes, the sizes, right? You kind of, like Danny talked about, and you'll get caught by some edge cases, right? Like you said, you'll run in, and I've seen that, right? Well, like, oh, I guess I have to actually move this somewhere else because this data's a little bit too big, So yeah, that stuff will definitely pop up. I think that's a good thing because it helps you learn your data. You'll become more of the data expert, right? Because you'll be the person that knows like, hey, I know all about these data source or these files, right? You got it in your head because you weren't just kind of like ignoring it. Like, I'm over here in my Spark, I don't really care about all you little files over there, right? Now you actually understand the data and the sizes and how often they come and how big they are, right? It's important to know that stuff, right? To become an expert or to be seen as the expert. So there can't be downsides when you kind of like stub your toe, but there's like upsides to it too, because I think part of learning is failing too. So it's okay to run into those things and find your way around them because you'll be smarter on the other side for sure.
That's awesome. I agree with that a lot. Like, it's interesting because like if you were like a distributed systems engineer in like say 2008, while like the cloud existed, a lot of times you were essentially purchasing hardware for the next 6 to 9 months or a year. And so there was a lot more thought that kind of went into what you need to operate and what you need to scale with what you believe your scale would be in those like next, months to come, year to come. And I think with a lot of that too, like you get into that, it's easy to spend someone else's money. Yeah. Like if you're on Amazon, for example, like, and so it's one of those things that kind of goes back to like, company culture as well. Like, do the employees understand that it costs money to do these things? It costs a lot of money to have like, an improperly, sized cluster to go run, if you had one of these jobs, right? 1 million lines, around 3 to 5 minutes, depending on like what you're choosing to use. Do you really, if that like you have that limitation of that 15 gigabytes of memory, the cores, you have what, 4 cores, something else like that in terms of like CPU on that box as well. Like, so it's very much a limiting factor, which is awesome to have. It's no different than like running on like the entry level like M1 laptop from 4 years ago. Like even I guess that was a little bit bigger, but still it's you're sizing that to essentially what runs on a laptop, which is an interesting thing that can help. Not everything's that big data problem. So I think we're just about at time. Seeing if there's any other comments right now.
No, I mean, we're top of the hour, so my take on this is like everybody else, you got questions, chime in on the...
You can find me somewhere.
Exactly. You can find Daniel somewhere. Also, we're on the Delta Lake Slack, so just chime questions there too. But this video, by the way, is already being broadcast to the Delta Lake YouTube channel. I chimed it into LinkedIn, by the way. It's just go.delta.io/YouTube. And then there you go. Bam. You can go watch this video there too. So I think we're good to go, considering we're already on the top of the hour, dude. So.
Awesome. Thanks for giving me the platform to talk. I appreciate it.
Awesome. Thanks for coming on.
Yeah.
Thanks a lot, Daniel. Have a good one, man.
Bye, everyone.